Assalamu alaikum. My name is Dr. Iqbal. Now I'm going to teach you function of two variables or partial derivatives. Now we have question. If u is equal to 1 minus 2xy plus y square power minus half, and we have to prove that x partial u or partial x minus partial u or partial y times y is equal to y square u cube. We can read in another way, partial u divided by partial x, can say like dou u or dou x, or partial u or partial x. Anyway, so for prove this equation, we're going to take left hand side, and for left hand side we have two partial derivatives here. First we are going to calculate partial derivatives and then plug in this expression. So we have u is equal to 1 minus 2xy plus y square power minus half, and we're going to take derivative with respect to x. This is partial x. Dou u or dou x is equal to minus, power times base. Base is 1 minus 2xy plus y square, and power minus 1 times derivative of base. Base is 1 minus 2xy plus y square again, and now minus half here, and this one we keep same, 1 minus 2xy plus y square power minus, minus half minus 1 is minus 2, and partial derivative of 1 minus 2xy plus y square. Partial derivative of with respect to x, we are taking here is in first term 1 at 1, because 1 is constant, there's no change, so derivative would be 0. And y square with respect to x, we treat a constant because it's partial, not dx, it's a partial x, so we treat y as a constant, and then derivative would be 0. So just only second term, we just eliminate x, just minus 2y, because partial x or partial x would be 1, right? 2 times 1 and y, it means 2y, and minus sign here is minus 2y, and then this minus 2 cancel each other, and then becomes y times 1 minus 2xy plus y square power minus 2, and we can write minus 2 like minus 1 over 2 multiply 3, no much difference, minus 1 over 2 multiply 3 is minus 2, and then partial u or partial x is equal to y, and this term 1 minus 2xy plus y square power minus half is equal to u, right? So we we substitute u, and power is 3, and y u cube. Okay, and then you see here we know formula x power a into b, we can write as x power a again power b. Now a second partial derivative is partial u or partial y. Now we are going to calculate here. Again we take u, again 1 minus 2xy plus y square power minus half, partial u or partial y, and the same power times base power minus 1, partial derivative of base. Now we are taking with respect to y, that's why we write here y, and then partial u or partial y is equal to minus half, same here, and partial y over partial dou over dou y of 1 minus 2xy plus y square, right? So here is 1 is constant, only 1 is constant here, and for 2 minus 2xy, y would be 1 and becomes minus 2x, and for y square if we take derivative, partial derivative, then comes 2y, and we take common minus 2 common outside, and x becomes x minus y in bracket, and this minus 2 will be cancelled with this 2, and again this one is a u cube times x minus y, and then we multiply, we open the bracket, then x u cube minus y u cube, right? Taking left hand side right now, x partial u over partial x minus y partial u over partial y, you can say like another way, x w over x minus y w over y, and then we plug in w over x, we already computed, which is y u cube, and we plug in here, and for w over y we plug in here, and then see here xy u cube minus times minus plus y times y square u cube. These two terms cancel because same, and comes out y square u cube. Proof, left hand side and right hand side. And now we move to another question. If u is equal to x cube plus y cube, where x is equal to a cos t, y is equal to b sin t, find du dt and verify the result. Actually, this one question is two questions. So we have u is equal to x cube plus y cube, x is equal to a cos t, y is equal to b sin t, right? So u is a function of x and y, right? And we are taking a total differential. We know du is equal to w over dx dx plus w over y dy, right? And we have to compute here in question is mentioned in question du or dt, not d only. Du or dt is partial u or partial x, dx or dt, partial u or partial y, dy dt. Okay, now three equations we have. So for du or dt, we have to compute first w over x, w over y, then dx over dt, dy over dt. It's different, w over x, x over t is different. It is a partial derivative, this is total derivatives. If we're taking derivative with respect to t, x and y also be treated as a variable, but in partial derivative, if we are taking derivative with respect to x only be treated like variable. Anyway, for w over x, u is x cube plus y cube, and we're taking w over x, and then y treated as I said earlier, and 3x square here. For w over y, u is equal to x cube plus y cube. Again, if we take partial u over partial y, and x will be eliminated, and y cube, derivative of y cube is 3y square, and dx over dt, x is equal to a cos t we have given, and dx over dt is a times derivative of cos, derivative of cos is minus sin t, right? Y is equal to b sin t, dy dt is b, derivative of sine is cos, b cos t. And then we plug in equation number 3, and then see here, so w over x is 3x squared, dx over dt is minus a sin t, plus w over y, and dy dt. We plug in here, and then simplify further, and then we get it. Now we are going to verify. Now verification, we're going to u is equal to x cube plus y cube. We substitute x is equal to a cos t, y is equal to a b sin t, and we plug in du over dt is equal to 3. Now taking derivatives, a cube is constant, power is cos cos cube t, right? Power is 3. Power, we are taking power rule. We are using power rule. Power into base, power less 1, derivative of base is cos t here, and similarly here b cube is constant, we take outside, and power is 3 power less 1, where 3 minus 1 is 2 sine square dot dt, base is here is sine t, and then 3a cube cos square derivative of cos minus sine t plus 3b cube sine square t derivative of sine t is cos t, and then we simplify further, and then dot dt is equal to minus 3a cube cos square t sine t plus 3b cube sine square t cos t, and see here results 4 and 5 are the same, and then we verify. Thank you for watching. Please subscribe my channel. Bye bye.